We're going to cover all these topics today: algebra of functions and composition. Let's start with that. The sum, difference, product, and quotient of functions. Given two functions f and g, then the function f plus g, f minus g, f times g, and f over g or f divided by g are defined as these symbols. So the first one, when you see f plus g of x, that's all it means is you take these two functions and you add them up. We've done this before. They're giving you two polynomials and they ask you to add polynomials, and basically that's all we're doing here. F minus g of x means you take those two functions or those two polynomials and you subtract them. This means you multiply them. Okay, the next one means you divide them. And you notice that we cannot have 0 at the bottom of the fraction, so you make a little note here that g of x cannot be equal to 0. So these are pretty simple notations. So let's take a look at the example here. Given g of x equal to 4x, h of x is equal to x squared minus 3x, k of x is given to us as x minus 2. We want to find g plus h of x. So according to the definition we just learned, so all it means is just add these two functions. You take g of x, which is 4x, and add it to h of x, which is x squared minus 3x, and we all should know how to add polynomials by now. If you have to subtract the functions, you write it as find h minus g of x. So this is, we have h of x minus g of x. So you take those two functions and you subtract them. So you're subtracting polynomials. Multiplying them the same way, you take, in this case, g of x and multiply it by k of x. So by now we should all know how to multiply polynomials. You distribute, and dividing the same way. We learn how to divide polynomials. In this case, if it's factorable, we factor them. Sometimes we need to use the long division. In this case, you see the little note here that x cannot be equal to 2, x cannot be equal to 0, because we don't want to make this undefined. So we make these little notes there. So before I move on, I want to make sure we're okay with this concept. So I'll give you some examples to do. So can I see a check mark in front of your name if you all can follow what we're doing so far? Questions, comments? No, it's time. Okay, will you respond except Leah, you're not there anymore? Okay. Leah left. Okay, good. We all okay with this? Let's take a quick example here. If f of x is given to me as x minus 1, g of x is given to me as 5x squared plus x, h of x is given to me as x squared, we want to find these. So this one would be f of x plus g of x. Well, f of x is given to me as x minus 1, and g of x is given to me as 5x squared plus x. So you basically add these up. So you would get x minus 1 plus 5x squared plus x. You combine like terms, you write them in order. So here we get plus 2x minus 1. So you add the polynomials. For the second one, you take g of x then minus f of x. So look for g of x given to me as 5x squared plus x minus f of x is given to me as x minus 1. So we need to distribute now. So we get 5x squared plus x minus x plus 1. Don't forget to distribute these. It's like a minus 1 out here. So you would get 5x squared. Looks like this add up to 0. So we would put plus 1. Okay. For the next one, that means g of h, well, with x. G of x times h of x. So g of x is given to me as 5x squared plus x, and h of x is equal to x squared. And then we can distribute here. So you get 5x to the power of 4 plus x to the power of 3. And that's how we do that one. For number 4, this means f of x over h of x. So f of x is given to me as x minus 1. H of x given to me as x squared. Okay, I want somebody in class tell me what do I do after this? Can I simplify this or is it done? If anybody with the microphone, we can dial the mic. There's a few students just logged in. Okay, can I just leave it like that, or can I simplify that?
I think it stays like that.
Yeah, Ray, you're right. We can just leave it like that because we cannot reduce x with x squared unless we separate that from 1. So we're good. So can I see a check mark in front of your name if all okay with this concept, how to add, subtract, multiply, divide functions? Right, so we saw how to add, subtract, multiply, divide functions, algebra functions. The next concept here is composition of functions. Let's take a look at that. Composition of functions. The composition of f and g, denoted by f in this little symbol, little circle, g is defined by the rule. And then you have f, the little symbol, little circle, g of x is equal to that. What that means is f of g of x, basically. So in this case, provided that g of x is in the domain of f, and then there's a little note here, composition of f with respect to g is also that f compose g. So this is a symbol you need to know in order to do problems like this. Composition function. So composing functions. Given f of x is equal to x minus 5 and g of x equal to x squared, and you have n of x is equal to square root of x plus 2, you want to find composition of f with respect to g. So f of g of x. So in this case, let's go through these examples together, make sure we can follow this. So what we have here is we want to find f of g of x. So first of all, you need to know the definition here. So every time you see this, you want to replace it with f of g of x. That's the first thing you do. You change this to this, so you get rid of this little symbol. They don't have this anymore. Alright, that's the first step. Now, g of x is given to me. It's right here. So what that is f of, you substitute that x squared here like you see here. So you substitute g of x with what's given to me. So you want to find what f of x squared is. In order to find f of anything, you need to note. The note here, you need to know what f of x is. If I know what f of x is, then I can find f of 1, f of 2, f of x squared, f of anything else. So f of x is given to me as x minus 5. So can somebody quickly, this is an example. Can somebody tell me very quickly what is f of 0 would be here then? Okay, anybody with the mic, grab the mic. Let's do this quickly so we can move on faster with this. F of x equal to x minus 5. So can somebody tell me what f of 0 is? You substitute for each x0. Okay, go ahead. Go on. Ivan, go ahead.
What is it to be x minus 0?
Okay, when you explain the steps, go through the detail, because again, if, students are going to review this later. So tell me, if f of x equal to x minus 5, explain to me about how do you find f of 0, and tell me what the answer would be. Go ahead.
You plug in 0 for x.
Okay, plug 0 for x, you substitute that. If we already see x, what do you get then? That would be equal to what?
Negative 5.
Minus 5. Very good. Okay, so what would be, very good. What would be, just let's take a look at a few more examples. How about f of 1? Anyone else wants to try? What's f of 1 would be equal to then? It's a simple example I'm asking you, so let's move through this quickly. F of 1 would be what, anyone?
Negative 4.
So again, explain what you do. It's 1. You said negative 4. So the 1 minus 5 is equal to negative 4. Very good. So I can find f of anything. If I would put f of a little flower here, it doesn't have to be a number. It could be a symbol, like that. I put a little flower. So this would be equal to this little flower. Minus 5. So it doesn't have to be a number. So in that case, what would be f of x squared then would be equal to? You substitute for each x here, basically you just substitute that x squared. Right? This is x squared. So we see why we have x squared minus 5 here then. That would be the composition of f of x. Okay, so they read that as the symbol here, f compose g. You could say g compose f. If I say g,
this is Jared. What's
compose f.
Compose mean?
That's all it means is you just take this little symbol and you change it to, in this case, g of f of x. Okay, that's all it means. This is the definition of that right there. So you want to eliminate this little funny symbols and the name compose. You take it out and then you replace it with this symbol here. And then if somebody give me f of x and g of x, then I can calculate it. So the composition of f and g, this is the symbol for it. It's defined as this. You just have to, first step is you have to remember that what this little symbol replaces with what? It replaces with this expression here. So let's take a look at another example here. This is another example. F of x is given to me as x minus 5. G of x is given to me as x squared. Again, same, n of x equal to square of x plus 2. We're going to find g of f of x. So first thing you do is you take this symbol out and replace it by this. So Jared, you asked me what that means. Do you follow up to this point? Can you remember that every time you see this little funny symbol here, you can rewrite it as this? You're okay with this so far? Jared? Just remember this for now. Okay, so then again, f of x has to be given to me. F of x has to look for my f of x here. It's right there. So what you do is you substitute that here. So they're really asking you what is g of this stuff here is. Again, in order to find g of anything, I have to start with g of x. The g of x is given to me as x squared. So again, g of anything else I can find. In this case, they want me to find what is g of x minus 5 is. That's what they want me to find. So, Jared, can you tell me what g of x minus 5 would be then, in this case?
X squared?
No, if g of x is equal to x squared, what is g of x minus 5 would be? You replace whatever you have in red with the variable x in g of x. That's all it is. So you want to try it again?
I'm lost.
Well, it's right there. Okay, well, the answer is up here, actually, but I want to see if you can understand it. Okay, can somebody else help Jared here? Somebody explain this? Who wants to explain this? What's going on? Okay, see, Margarita, Jim, you guys are typing. Can you grab your mic and talk about this?
Wait, x will be x squared minus 5?
X squared minus 5. You replace x with all this stuff here.
So in parentheses, x minus 5 to the square squared?
There you go. Yeah, that's right. That's right. That's correct. It says right here. So if g of x equal to x squared, g of x minus 5 would be x minus 5 squared. Okay, Margarita type x minus 5 squared. You're right. Margarita, you don't have a microphone today? How come you're not talking?
I do have a mic.
Okay, Jim says x minus. Okay, good. The other one. Go ahead and use your mic so we can, because students won't be able to see this chat later, maybe. Okay, let me see. Alton Sue says, why not x squared minus 5? X squared. Okay, the question is why not x squared minus 5? Okay, so you would do this if g of x were equal to x squared minus 5. Let me just maybe have another example here. If g of x were x squared minus 5, okay, then g of x squared minus 5 would be, maybe that would be a good question to ask to make this a little bit more clear. If g of x were x squared minus 5, Caitlin Sue, do you have a microphone? Today you asked the question, I wonder if you follow that. Do you have your mic today? No. That's okay. Okay, Jim says you have a lot of background noise on your mic. Okay. Can somebody with a good mic tell me what would be g of x squared minus 5? This is another example. This is another example, just to understand what we're doing here. If g of x was equal to x squared minus 5, what would be g of x squared minus 5? Okay, who wants to try that? We're supposed to talk about this. Bobby, do you follow what we're doing?
Can you ask the question again?
You want to try? Yes, please. Margarita, go ahead. What's the question?
No, I wanted to know what your question was. I wasn't sure what you were.
The question is, if g of x is equal to x squared minus 5, what is g of x squared minus 5 would be? That's all it means. You substitute for each x in g of x all this stuff here. Would be enough hint?
So would it be like x squared minus 5 minus 5?
Right.
I mean,
Ray says you put x squared minus 5, and then you have to square it again, right? Minus 5. Because you replace only x with this stuff here. Does that make sense? Okay, so let me erase this here. Somebody asked why that. This is just another example to just make sure you understand what we're doing here. Okay, let me put another example here once again. If g of x is equal to x squared, I should be able to find what g of 1 is, would be 1 squared. G of 2 would be 2 squared. G of anything, g of t would be t squared. G of x minus 5 would be x minus 5 squared. Does that make sense? Do you have anything? If I want to know what g of a little symbol here. Okay? You just put that symbol there. That's all you do. Put this little symbol here, little man. Erase. Square. Does that make sense so far? Can I see a check mark for the name if all can follow this concept? Of course, here we can expand this here, right? This will become x squared minus 10x. I hope everybody remember that. A minus b squared is equal to a squared minus 2ab plus b squared. Everybody remember this, right? Okay, check mark if you all follow this concept so far. If not, you can spend a little more time on this. Alright, Bobby, are you there? Leah, you're not responding again. Bobby, very good. It looks like there some people just logged in late. Okay, Leah not responding. Okay, let's see who's not following what we're doing. It's everybody okay so far. Exponential looks like who joined us.
I'm a little confused. The g in parentheses, and you have the function of x. So, function of fx is x squared, or anything, and then it goes to down to g is x minus 5 squared.
So what part you don't follow?
What I just said.
Okay, let me make sure I understand this. Let's look at this example here. If g of x is equal to x squared, we have a function called g of x in terms of x, which is x squared. Do you follow what g of 1 is then? Do you follow that?
Yeah, I follow all of that. And then the x minus 5 squared is in place of x. But why is f is of g of x squared, and then x squared is x minus 5 squared?
This part here? This step here, right? You're referring to this one with the arrow I'm pointing at? Is that what you're talking about?
Oh, you erased the rest of the stuff, the x minus 5 stuff.
Okay, well, I can do it again. So if f of
in the beginning of the thing,
x
you have x
is
of
equal
x,
to x
and then
squared.
you got x squared, and then the g of x was going to be, I think you're on the wrong page, that's what's going on. Yeah, you got to go to page 13, or slide 13.
This one, okay, got it. Okay, thank you. Right, here you go. So if g of x is equal to x squared, g of 1 is equal to 1 squared, g of 2 is equal to 2 squared, g of 2 is equal to 2 squared, g of x minus 5 would be x minus 5 squared. Let me put one example right below that. Maybe that would make it a little easier for you to follow.
You have g
okay,
is
look
a
at
function,
this
and f is a function, and f is inside g?
Yeah, let me give you one example. I think this will help you to understand this a little bit better, Jared. If g of x is equal to x squared minus 1, okay, what would be g of x minus 5? Can you tell me that?
I think it's going to be x squared minus, no, x squared minus 1 because x. You're replacing the x.
Look, you're replacing x with x minus 5. So it would be x minus 5 squared, then minus 1. Do you get it?
Yeah, I get that part, but over here when it says given g compose f of x, and then you said set that equal to g, g the function with the f of function is inside g. Or am I saying that wrong?
No, you're saying right. Every time you see this symbol here, you replace it with this.
So g a function of x would be, yeah, g function of x, or no, g function of f function of x. That's what the g in parentheses f inside parentheses x.
Yes. That's what this is. Exactly. Let me take a look at one more example here. Maybe that would, and then we'll look at some to do it, together. So let's take a look at this example here. F of x is given to me as x minus 5. G of x is given to me as x squared. And again, n of x equal to square root of x plus 2. We're going to find composition of n with respect to f. So first thing we do is we take this here, this symbol here, take this little symbol away, and you replace it with this. And you follow that now, right? So what I do is I just take f of x and replace it with what's given to me. F of x is given to me as x minus 5. So everywhere you see f of x, I put x minus 5. So you really have to evaluate what is n of x minus 5 is. In order to find this, put a question mark here, I have to start with what is n of x is. Okay, n of x is given to me as square root of x plus 2, then n of x minus 5 would be equal to, you look at that function and everywhere you see x, you substitute it with these values here, which is x minus 5. Okay, so this would be x minus 5, and the rest of the stuff stays the same, plus 2. Okay, so everybody follow up to this point? Question?
Yeah, I think I got it.
Good, okay. So this would be called, then you simplify this.
I don't know about the rest.
So you would get x minus 3. Well, if anybody else is not following, just put the x under my name so we can talk about it more. And I see check mark front up under this name, so I'm assuming that everybody is following so far what we're doing. Okay, I need to see. Look at some of you still chatting and sending messages in the chat room. Okay, good. Let's take a look at more examples here. Alright, let's take a look at, I'm going to do one of these and I'm going to ask you to do one yourself. So, first one, we have this one. F of composition of f with respect to g. So I'm going to replace it with f of g of x. That's the first thing we do, to get rid of this little symbol here. Okay. And then I would replace g of x is what's given to me. G of x is given to me as x plus 3. So I'm going to replace this with x plus 3. Okay, in order to find f of anything, I have to start with what f of x is. F of x is given to me as 2x squared. So f of x plus 3 would be a substitute. Everywhere I see x, I'm going to substitute it with this stuff here, x plus 3. There's only one place here we have x. Sometimes we have more than one place you see x. So replace each x with x plus 3. So that's what we have here. Of course, we can expand this to 2 times. It would be x squared. 2ab would be plus 6x plus 9. So I can write it as 2x squared plus 12x plus 18. Okay. So let me clear all the check mark in front of your name. Make sure we'll be okay with this first of all before I ask you to do the next two. Check mark if you all can follow this one, please. Okay. Flip your way. Okay, good. All right, I'm going to pause the recording for a second. For those of you viewing the session, now probably would be a good time to pause the session as well. And do number 6 and 7, and then continue, see if you are correct. For those of you doing this live, as soon as you're done with your solution for both of these, put the check mark in front of your name, then I'll continue with reviewing this. All right, you're back. Let's see who wants to go over number 6. Okay, you can grab a mic. Anyone? Oscar? You want to try number 6? Marina, how about you?
Okay.
All right, go ahead. So, explain to us how to start number 6. What do you do first?
First, you replace the composition and you make it g of f of x.
Okay. So you write this as get my pen back. Hold on. Okay. So you write this as g of f of x. So you get rid of the little funny symbol there. Okay, and then what do you do next?
And then we already know that f of x is 2x squared. So then you're going to find g of 2x squared.
Mm-hmm. Okay, so you have to find
g of x is x plus 3.
very good.
And so
Okay,
you
g of 6 is 3.
you just plug 2x squared into x.
2x squared is right there. So everywhere you see x in g function, you would replace 2x squared with that. Very good. Okay, so that would be equal to 2x squared plus 3. All right. Good. So someone else for number 7. Let's give a mic to Oscar. Did you say you have a mic today? No. Okay, from the top of the list, those of you put the check mark for every name. Bobby, are you there? You want to try number 7? Okay. Caitlin, still? Up with you. Number 7? Okay, Jared, you want to try number 7? I see you have light.
Yeah, sort of.
Okay, go ahead. Number 7.
Right.
Tell me what.
So
What do you do first?
H composed G of X is equal to H G of X.
Very good. Okay.
Alright, now we're going to look at what H is. H is the square root of X minus 1.
Okay, wait a minute. You want to know what G is, right? Not H. Because you say H of G of X. You care about what's inside the parentheses first, right? You look for G of X, right? Not H. Because what's inside is G of X, right? Forget about the H for a second.
Okay, so G, yeah, we're looking for G of X plus 3.
Yes.
I just switched it in my head.
Right.
Alright,
So that's what you're looking
now
for, right?
that we have G of X, now we can look at what H of X is.
Mm-hmm.
Yeah. And H
Okay,
of X is the square root of X minus 1.
Mm-hmm.
And
Okay,
then
go on.
we substitute what B is. So it's square root of X plus 3, close parentheses, minus 1.
Very good. So that's what you get inside the radical. You get X plus 3 minus 1. So this would be square root of X plus 2 then, right? So that's what this is. Square root of X plus 2. Very good. You got it.
Yeah.
Okay, so that's how you evaluate the composition. So we talked about algebra function, how to add, multiply, subtract, divide functions. We looked at composition of function, how to deal with that, and operation of functions. We'll look at that now. Now, let's take a look at this example. Given the functions defined by f of x is equal to x minus 7, and h of x is 2x to the power of 3, we want to find the function values if possible. So in this case, we want to find f times h of 3. So remember we said f of h of x is equal to f of x times h of x. Remember we did that? The only difference here is your x is actually the value. We're assigning a value for x, so it's 3. So this would be f of 3 times h of 3. So what is f of 3? Well, you look at the f function. Now f of x is equal to x minus 7. So f of 3 must be equal to 3 minus 7. Right? And what is h of 3? In this case would be minus 4. h of 3 then, we need to know what h of x is. H of x is given to me as 2x to the power of 3. So h of 3 would be 2 times 3 to the power of 3, which is equal to 2 times 27, right? So that's what we have here. We have minus 4 would be the value of f of 3. 2 times 27 would be the value of h of 3. When you multiply this together, we get 200 and minus 216. That's what f times h of 3 is. That should be pretty simple. Question, anyone? You can stop me if you don't follow any of these. Another example here. h over f of 7. That means h of 7 over f of 7. You evaluate what h of 7 is. In order to evaluate h of 7, you need to know what h of x is. So it's right there already. So you just substitute for each x7. That's what we have here. And we need to also evaluate what f of 7 is. Okay, somebody have a question? Go ahead. F of x is given to me as x minus 7, would be, in this case, 7 minus 7. In this case, we get undefined because f of 7 is 0, so it becomes undefined. Therefore, h over f of 7 is undefined. So somebody's having a question. Margarita, you have a question? Jared, you need to give the mic to another student. If you're not talking, release the mic, please. Thank you. Yes, Margarita, go ahead, please. What's the question, Margarita? You got the mic now.
I just asked if you could please slow down a little bit. I was having a little trouble catching up to you.
Oh, sure. So are you okay with this problem or the one before that?
The one before that, actually.
Are you okay with... Okay, this one here?
Yeah, I was writing down the steps
let's review this one with you.
I was writing down the steps.
Sure, no problem.
On the side.
Okay, so let's go ahead and see what part you don't follow. Do you follow what we're doing so far? So let's review this as you write it again. So here we have f of x, right there, and h of x. And then you want to find what f times h of 3 is. This is the same as f of 3 times h of 3. Just like f times h of x is equal to f of x times h of x is times. So f times h of 3 would be f of 3 times h of 3. To find f of 3, you look for f of x. F of x is x minus 7, so f of 3 would be 3 minus 7. So you substitute 3 for everywhere you see x here. And so as this one, h of 3 would be substitute 3 in h function, everywhere you see x. Do you follow that now?
Yes.
Okay, good. So let's, and then we went to the next page here. The only difference here would be division. H of 7 over f of 7. So you would have to find what h of 7 is. Again, h of 7, you look at h function, you substitute for each x7. In only one place you have x here. And for f of 7, you look at f function, you put 7 for each x in f function, which turns out to be, in this case, would be 7 minus 7 would be 0. We get 0 here, so that means it's undefined. Okay. Question on that, anyone? Are you done writing, Margarita?
Yes.
Okay, good. So let's take a look at the next example here. This is a composition function. So remember we said composition of h respect to f of x is the same as h of f of x. So in this case, instead of x, you have 2. So composition of h respect to f of 2 then would be equal to h of f of 2. So instead of x, we put 2. So in this case, you have to evaluate what f of 2 is. Remember, to find f of 2, you have to look for f of x. f of x is given to me as x minus 7. So f of 2, then we substitute for each x2 in the f function. That's what we have, minus 5 here. So f of 2 is equal to minus 5. Now we have to find what h of minus 5 is. To find h of anything, you have to look for h of x. h of x is given to me as 2 it's given to me as 2x to the power of 3. So h of minus 5, you substitute minus 5 for each x. Like that, right there. So that's why you get minus 250. So let me make sure we're okay with this before I move to the next screen. For the check mark under your name, everyone, if you're all okay with this page. X if you don't follow it. Caitlin Sue, are you there? Check mark if you follow, please. Jim, are you there? Leah? Tanisha? For every time I call your name and you're not responding, you're making notes here that you're not following the lecture. You need to follow throughout the lecture. Tanisha, you think this is good?
Yes,
Alright. Jim, are you there? Okay, thank you. Jim, how about you? Check mark if you guys there. Okay, Jim not responding. You are responding like that. So really good in this page. Let's move on. Okay. Let's go over this quickly. Alright, I want somebody to participate here for number 8. Just go over the steps. I will write it down. Okay. Who wants to do that? I'm going to clear your check mark. Put the check mark if you do have a microphone and you like to follow this, Ivan. Go ahead. Start with number 8. Tell us how to do this. Let's. I'm more concerned about the steps.
You have h times k. So your h. H is, so you plug your 2 for x plus 4.
Okay, wait a minute. You want to replace this. Remember, if I have h times k of x, okay, we replace it with h of x times k of x, right? So how do you replace this? Now instead of x, you have minus 2. So tell me how to rewrite this. Very good. That's the first thing you do. You have to rewrite this. So
now you plug
tell me what
h,
you do next.
Which is x plus 4.
So you look for h of x, which is x plus 4, and then now you go on.
Plug in negative 2 for x.
Good. So you have to evaluate h of negative 2. So you substitute for each x negative 2. And then what do you get?
2.
You get plus 2. Very good. So that will give me plus 2. Alright, so this would be plus 2 times. So how do you evaluate k of minus 2 now?
It's x squared minus 3.
So you start with k of x, which is x squared minus 3, and then you substitute for each x minus 2 again in k function. So what do you get if you do that? Negative 2 squared would be 4, right?
Minus 3 is 1.
1 minus 3 would equal to
1.
Equal to what? 1, right? So k of minus 2 is equal to 1. So 2 times 1 is equal to 2. So that would be the value of this. This would be equal to 2. Okay, very good. Good job, Ivan. Alright, let's clear the check mark. Okay, put a check mark in front of your name if you can do number 9. The same way we did. Jim, you said you have a mic. Because your microphone has a lot of backup. Let's try your mic today. Let's see how bad it is. Jim, go ahead and try it. Try it. Open your mic, please.
Hello? Okay.
Yeah, go ahead.
Okay.
Not too bad. Go ahead.
So number 9, you just do k over h. So first you find k, right? Which is...
First you have to rewrite this as, like, remember if I have k of h of x, I have to rewrite it as k of x over h of x. That's what I have to do. So in this case,
so it'll be,
you rewrite
k
of, go on.
K parentheses negative 4 over h of negative, okay. And then h
over what?
parentheses negative 4.
Yeah, h of negative. Okay.
H of negative.
So what is h? Right. How do you find k of negative 4?
So in order to find k of negative 4, first you find k of x, which is x squared minus 3, and you
very good.
You take the negative 4 and you plug it to where x is at, so you have negative 4 squared minus 3.
Very good. And what do you get if you do that?
16. Oh my god, I'm having a brain fart. 13.
Plus 13, very good.
Yeah.
So that would be 13. Okay, so the top of the fraction would be 13. So how do you find h of negative 4?
So you do the same thing. You find h of x, which is x plus 4, and then you take your the negative 4 and you plug into where x is at. So you have negative 4 plus 4, which cancels out and gives you 0.
Negative 4, that would be 0. So what was your conclusion here?
The answer would be 0.
What the whole thing is equal to 0, you said?
Right? Would that be right?
What is 13 over 0? Can I divide 0 into a number?
No.
No, you can't, right? How can you divide 0 into what time 0 give you 13?
Nothing.
0 times anything is 0, right?
Yeah.
So what would be the answer?
Oh, 13 then?
That's 5 the answer if you know. What is that?
Is it just 13?
No, 13 over 0 is not 13. Bobby typed the answer.
Oh, Marina typed in undefined. Sorry.
Undefined, yeah, very good. So the answer here would be undefined.
Okay, gotcha.
Does it make sense? undefined. We did that another example earlier. Remember we did this? This is how we come undefined.
Right.
Because yeah, we did that earlier. So yeah, that would be undefined.
Yeah.
Okay, good. All right, good job. Next, take a look at. Let's give the mic to someone else. I'm going to clear the check mark. Look, let's see somebody who didn't participate. Go put the check mark in front of your name. I do make a note every time you guys participate and give me an answer. It doesn't have to be correct answer. It just have to be your effort here. It's all new stuff. So, but it helps when we do this together to understand it. So number 10, check mark if you can do this. Marlene, you want to try that, please?
Okay, so
Marlene,
you find K compo H of 1. So for
composition of K of H of 1, so rewrite it to what?
I'm gonna rewrite I don't know how to say it, but H, first you find H of 1.
Okay, let's write down the formula first, okay? So composition of K respect to H of X, you rewrite this as K of H of X. That's how you say it.
Okay, thank you.
So composition of K respect to H of 1 would be equal to, try to say it, would be equal to what? K of
compo H of 1? Or no compo, just H of 1?
You don't say compo anymore because you take, yes, you take that, when you write it as K of H of 1, you don't have compos anymore, you take it away. So you say K of H of 1.
Okay.
That's all you say. Okay, so what do you do next?
You plug in the 1, 2, or first find H, which is X plus 4.
Okay, so first you have to find what H of 1 is, you're right. So you look for H of X first. H of X is equal to
X plus 4.
X plus 4, very good. So what do you do next?
And then you plug in 1.
Okay, for X, right?
Yep. Which is 5.
Okay, so what do we get?
5.
So H of 1 is equal to 5. So that's what this is, right?
Yeah. Yes. And
so
then
you really want to find what is K of 5 is then, right?
Right. So then you plug in.
How do you find K of 5?
First you find K of X, which is K or X squared minus 3. And then you plug in the 5 for the X. 25 minus 3.
Very good.
Which is 22.
Yes, exactly. So you put square here. So 25 minus 3 is equal to 22. That's exactly right. So this would be equal to 22. Excellent. Okay, I need to see a check mark in front of everyone's name if you all know how to do this. So we can move on.
I'm sorry, what was the answer for that?
I'm sorry, for what?
For number, oh, sorry.
For number 10? It's there, right? So this would be, right, this would be on. Undefined for number 9, 22 for that. Okay, I'm going to look through your check marks now. Now, Salter, are you there? Yes. Jim is still away. Oscar, are you there? Oscar not there. All right, good. So let's take a look at the graph of some of these. So this problem here requires you to look at the graph to find the answer here. They're giving you two graphs, f of x and g of x. G of x is in different colors. Here, as you see, you have g of x here, and we have f of x here in blue. So we want to find g of 2. To find g of 2, so it means when x is equal to 2, g of 2 or y is equal to minus 1. So if x is equal to 2, let's take a look at, remember we have to look at the g function, which is this one. If x is equal to 2, is right here, you go and see where this graph gonna hit y-axis. It's right here. You see that minus 1. So in this case, if x is equal to 2, y is equal to minus 1, and this corresponds to for the g function. This is the g function. Okay, so we have to read the numbers of the graph. So if I want to find f minus g of minus 3 is, so in this case, first I find, well, let's translate this into what it is. This means you have f of minus 3 minus g of minus 3, right? This is right here. So f of minus 3, you look at the f function, this is the f function, you're saying at x equal to minus 3 what y is. If x equal to minus 3, this is minus 3, you come down here, looks like y is equal to minus 2. This is the point that we're talking about. So at this point here, if x equal to minus 3, y is equal to minus 2. So that's why we put minus 2 here. And for the next one, you look at the g function, which is this one here, g of minus 3. G of minus 3 means if at x equal to minus 3, come up here, and it looks like this point here, they're referring to this point here. So if x equal to minus 3 in g function, y is equal to 3. So that's why we have 3 here. So minus 2 minus 3 equal to minus 5. So it's pretty simple looking at the graph for that. So can I see a check mark front of your name if you all can follow this concept here? Pretty simple. Check marks if you're all okay with this. If I don't see check mark front of everyone's name, I mean you don't follow it or you're not there. Okay. Okay, all right. Now let's take a look at the next one. If I want to know what g of f of 5 is, let's translate this. This is g of 5 over f of 5. Right? That's what it is. G of 5 means when x equal to 5 in g function, 1, 2, 3, 4, 5, this right here, what is y is. Okay? So if you look at the g function, which is this is g function, g of 5, if x equal to 5, 1, 2, 3, 4, 5, you have to go up, and this is the point of intersection, which is 1. So it looks like if x equal to 5, y is equal to 1. That's why this is 1. F of 5, you look at the f function, then x is equal to 5, y is equal to 0. So for the other function, then x is equal to 5, y is equal to 0. So that's why this is 0, and that's why this becomes undefined again. Okay. Alright, I think that's pretty clear. Now, composition of f with respect to g of minus 2. Again, we have to translate this into f of g of minus 2. So when you translate this, you don't have this little funny symbol anymore. You see that? And you don't say the word composition anymore. You just say f of g of minus 2. So what is g of minus 2? You look at the g function with x equal to minus 2, which is right here. Where does it hit the y-axis? It is this point right there. So if in the g function when x equal to minus 2, y is equal to 3. So that's why this is 3. This is 3. So f of 3, you look at the f function, which is right here, when x equal to 3, where my graph gonna hit y-axis is 1. This is the point you're talking about. So if x equal to 3, y is equal to 1. So that's why this is equal to 1. Okay, once again, I need to see a check mark in front of your name if you follow this concept here with this example. Check mark, please, everyone. Jim, are you there? You were away for a while. Are you back? I still don't see any response. Oscar, are you there? Jim is back. Okay, good. Everybody okay with this concept? All right. Let me give you a few minutes to evaluate 11, 12, 13, 14 quickly, please. Looking at those two graphs. And for those of you viewing the recording, now would be a good time to pause the session and write your answer and compare it. Those of you who are following this live, put the check mark in front of your name when you are done with these 4 examples, and we continue. Okay, who wants to tell me what f of 3 is? Okay, Marina, do you have a way to check mark in front of your name? So I see only one check mark in front of your name, so that means you guys have a problem with this, or nobody's done with this? Alright, let me clear a check mark from everyone. Number 11, who's done with number 11? Please do the check mark. Jared, what did you get for number 11? Go on. G of 3. Okay, Jared, you want to try?
I'm not sure.
Well, look at the G function. Let's work this out together. G function, which one is G function? You see, this is a G function, right?
It would be the pink line.
The pink one, yeah. G of x that's the behavior of G of x. We care about what's going on as x equal to 3. So basically, we look at the G function, G of x. We want to know if x is equal to 3. When x is equal to 3, what is y? Or what is G of x is? Let's take a look. X equal to 3 is right here, right? X equal to 3. Can you follow the graph and tell me?
Just look at the dots at the y's too.
Yeah, that's it, right there. So if x equal to 3, y is equal to 2, so the answer here would be 2. Simple as that. Okay? Just stay on line with number 12. Let's take a look at number 12. F plus g of minus 4. How do you write this without the symbol? Do you remember? You write it as what? F of somebody else wants to.
F negative 4 plus G negative 4.
Right. F of negative 4. So you write F of negative 4 plus G of negative 4. Very good. So what is F of negative 4 quickly, Yvonne? If you look at F function, which is right here, that's F function. If x equal to negative 4, which is right here, what is, go on, Yvonne?
2.
2. X equal to negative 4, F of x equal to 2. So this would be 2. So can you tell me what G of negative 4 is, Yvonne?
G of negative 4, 0. No. Negative 2.
Negative 2, very good. This point right there. G of negative 4 is negative 2. Okay, so that would be equal to 0 then, right? Good.
Right.
All right. For number 13, Tanisha, you said you got it. Number 13. You want to tell me how do you do number 13 then? Tanisha,
That one's for number 13. That one's for number 11.
Okay, number 13. So how do you write this without that symbol? That would be F of what? F of 2 over what?
G of 2.
Yeah, F of 2 over G of 2. So look at the F function. Look at the F function. If x equal to 2, y is equal to 4. If x is equal to 2, y is equal to 4. So that would be 4. Look at the G function. If x is equal to 2, y is equal to 1. This point. This is the point that we're talking about. If x is equal to 2, y is equal to 1. So it's equal to 4. Okay? Who wants to try 14? Check mark if you know. Number 14. Okay, Marina, you want to try number 14? How do you write this down? How do you start this?
Sure. So you write G of F of negative 2.
As what?
Wait. G of F of negative 2.
G of F of negative 2, very good. And then you find what next?
And then you have to find what F of negative 2 is first.
What is that?
It is 3.
3, right. At this point right there. If x equal to negative 2, y is equal to 3.
And then you find what G of 3 is.
G of 3. So now you look for G of 3. So look at the G function. And then if x equal to 3, what is y?
2.
You got it already with 2. Good job. That's 2. Alright, this is how you look at this graphically. Great. So let's take a look at the next concept here. Inverse function. Now, inverse function should be pretty simple. When we talk about we have set of numbers like if f of x is equal to if f of x okay. There's here. Okay. Let's go to the next question. If f of x is equal to these values, right? These are the pairs for f of x. If x is equal to 1, y is equal to 4, if x is equal to 2.5, y is equal to 10, if x is equal to 4, y is equal to 16. In this case, x and y could correspond to anything here. They're saying that for this example, if x, for example, the function f relates the weight of a package of deli meat x to y would be the cost. So for 1 pound of the meat, the cost would be $4. For 2.5 pounds, the cost would be $10. For 4 pounds, the cost would be $16. So if I were going to write the inverse of that, you just simply switch the position of x and y, basically. So if for 4 pounds, the cost would be 1. For 10 pounds, the cost would be $2.5. $2.50. For 16 pounds, the cost would be $4. So this would be the inverse. So the position of x and y switches here when we talk about the inverse function. So let's take a look at the example here. Now, if it is an inverse function, I'll show you the one example how to actually evaluate the inverse right there. So in order to see if two functions are inverse of each other, so this is the one property that you need to know. If composition of f respect to g of x and composition of g respect to f of x equal to x has to be equal to x, then we can conclude from that f is a one-to-one function, then g is the inverse of f. Now, one-to-one function, first of all, you have to know what one-to-one function means. For the function of one-to-one function, if the x position doesn't repeat, so take a look at this example here. Now, this is not a one-to-one function because if I draw a horizontal line, the horizontal line would intercept your graph at more than one point. So namely are these points here. So if x equal to -2, y is equal to 4. See, this would be x equal to -2, y is equal to 4. Now if x equal to 2, also y is equal to 4. So if you look at the set of numbers in your function, this is -2 and 4, 2 and 4. So if you see, of course there are more points here, but as soon as you detect the same value for y, that x are different points, like in this case here, that means you're looking at 2 points next to each other on the graph. So that violates the definition of one-to-one function. So this is not one-to-one function. So you can draw a horizontal line. If that horizontal line intercepts your graph at more than one point, then you can say that's not a one-to-one function. If it doesn't, like in this case, this is a one-to-one function, right? Because if I draw a line through this, if I draw the horizontal line here, going to intercept my graph at one point and one point only throughout the graph, right? However, this is not a one-to-one function because if I draw a horizontal line, it's going to intercept my graph at more than one point. Again, if I look at the points, like at x equal to -2, and also if x equal to 2, the values of y, which is repeat itself, which is 2. So as soon as you detect that this value of y repeat itself, it means it's not one-to-one function. One-to-one function. Now we did the vertical test before. If you remember, we did the vertical test if something is a function or not. So if I have this here, this parabola here, this would pass the vertical function because it's going to intercept the graph only at one point. So this is a function, but it's not a one-to-one function. Okay, but not one-to-one function, because it does pass the vertical test. It shows that it's a function, but it's not a vertical. It's not a one-to-one function because it is not going to pass the horizontal test. Okay, so that's how you test whether it's a vertical test would show us if it's a function. Horizontal test, it would show us if it's a one-to-one function or not. So basically that's what they're talking about here, whether it's a one-to-one function. In order two functions to be inverse of each other, then there has to be one-to-one function first of all. So if f is one-to-one function, it means if it passed that horizontal test, then g of x is the inverse of f if and only if this condition, if f of g of x or g of f of x, which turns out to be x. Not the same number, has to be exactly x in order to be inverse of each other. So if you look at this example here, f of x is given to me as 5x plus 4. G of x is given to me as x minus 4 over 5. So if I want to know if these two are inverse of each other, then if I evaluate f of g of x, or f composition to g, and if I evaluate g of f of x, or g composition to f, if I evaluate this and both turns out to be equal to x, then I conclude from there that these two are inverse of each other. In this case, turns out to be inverse of each other. Now let's take a look at how to find the inverse function. So if f of x is equal to 5x plus 4, or can call it y is equal to 5x plus 4. To find the inverse of this function, there are two steps involved. Step number one is you replace x with y, y with x. That's what you do first. So everywhere you see y, you replace it with x. Everywhere you see x, you replace it with y. And then step number two, you solve for y. Pretty simple steps actually. You solve for y. So if I solve for y here, I have to subtract 4 from both sides of the equation, and you divide both sides by 5. So that's what I get. Y would be equal to x minus 4 over 5. Now this is supposed to be an inverse function. Inverse. So they put the symbol here, minus 1 on top of that. That is the inverse function. Or sometimes you use it as f of minus 1 of x. Same thing. And as you see here right there, that becomes this. See, if f of x is 5x plus 4, if I replace x with y, y with x, and solve for y, what I find here would be the inverse of the other one, which is right there. And then if I find composition of f with respect to x, or composition of g with respect to f, it turns out to be x. That would be another test if they're inverse of each other. So if I look at the g function, if I g of x is equal to x minus 4 over 5. So if I call it y is equal to x minus 4 over 5. If I want to find the inverse of g or inverse of y, we do the same thing again. We replace x with y, y with x. Step number one. Step number two is solve for y. If I solve for y here, how do I solve for y? You just multiply. You multiply both sides of the equation here for. You can cross multiply here. Less than 10. There's my pen. Here it is. Okay, so here we're going to solve for y. In order to solve for y, you can put the denominator of 1 here, and you can cross multiply this. So that would be 5x is equal to y minus 4, and then to solve for y, I can add 4 to both sides of the equation like that, and then you see that y would be equal to 5x. You see that y would be equal to 5x plus 4. So you see how to actually evaluate that. How to evaluate the function. So if f of x is given to me as 5x plus 4, I can find its inverse function like I did here. So the two steps involved. You substitute x with y, y with x, and then solve for y. You can find the inverse. And if you actually plot some numbers there, if x is equal to 1 in f function, y would be equal to, what would be y would be equal to? Let's take a look at that. If x is equal to 1 in this function, y would be equal to 5 plus 4, which is 9. Now what's going to happen with the inverse function, these values switched around. If x is equal to 9 in this case, so y must be equal to 1. So 9 minus 4 would be equal to 5 over 5, that would be equal to 1. You see how it switches around? That's the behavior of the inverse function. If x is equal to 1, y is equal to 9. If x is equal to 9, y is equal to 1. This value switches around when we look at the inverse function. Okay, so let me make sure with you, understand the concept. If you want to talk about this right now, this is the time to explore this a little bit more. So can I see a check mark in front of your name first of all? We understand the concept of the inverse function, how to find the inverse function, and how to use a composition to verify whether these two functions are inverse of each other. Remember, you have to be equal to x, and then you find the compositions. Looks like everybody put a check mark. Jared, I don't see a check mark in front of your name. Are you confused on any of these concepts? Is that why you put a check mark now? Okay, good. So everybody good with that. So let's take a look at some examples here. So if I show that these two functions are inverse of each other, I don't want you to calculate it because it's already given to you. So in this case, we need to find f of composition of f respect to g, and see that come out to be equal to x, and at the same time we do g of f of x and see if that's going to be equal to x. So what I'm going to do is I'm going to pause the session for a second. For those of you again viewing this later, I suggest you pause the session and calculate composition of f respect to g and g respect to f, and see if you get x. If you get x, then the answer would be yes, these two are inverse of each other. If it's not, then they are not inverse of each other. And then we're actually going to calculate these both ways, see if it verify that as well. So I'm going to pause the session for a second, stop talking, and ask you to put a check mark in front of your name, and when you're done with this process. All right. Okay, let's see who can help me out here to verify whether f of x and g of x are inverse of each other by finding a composition of these two. I see few check marks only in front of your name, and we should be able to find the composition of f with respect to g and composition of g with respect to f already. We already had enough examples there. So anyone else? I have only 2 check marks. Alright, let's see. Jared, let's go ahead and help me out. How do you find f of g of x? Let's start with that. Go on, please.
The f composed of g of x is equal to f g of x.
Very good. So first we get rid of this little funny symbol. So you write as f of g of x, and then what do you do next?
You just kind of plug g of x and stuff in there.
Right, the g of x is given to me right here. So I'm going to put it right there.
First of all, the f of x is 3x minus 2.
Right, so now I have to go back to f of x. Good job.
Then we want to plug the g of x in for the x, which would make it 3 parentheses x plus 2 over 3 in parentheses minus 2.
Excellent. Right. So you would go ahead
everything
and
just kind of cancels itself.
Right. So everything cancels. You're absolutely right. So you substitute for each x, x plus 2 over 3, and when you do that, you see this 3 and this 3 cancels each other out. You get x plus 2 minus 2. So you do get x as you wanted as the first part of the property here. It says inverse functions are inverse of each other if f of g of x turns out to be x. So I did satisfy this first condition that showed that f of g of x is indeed equal to x. Again, it has to be x. It doesn't have to be the same number. It has to be exactly x when you do this. So yes, we get that. All right. So go on, Jared. How do you find g of f of x now the same way?
So we flip the things around. So it's g compose f of x equal to it's g, function of g is the function of fx.
Good. Okay.
So,
and then now, what do you do next?
Since we know that g of x is x plus 2 over 3, now you put that down, and now you put replace the x with the f of x. So it's
right.
3x minus 2 plus 2 over 3.
That's right. So over here, to find the g of x minus 2, you have to find what g of x is. G of x is known to us as x plus 2 over 3. Now you want to find what is g of x minus 2 is. So everywhere you see x, you put x minus 2 in that g function. And then you notice that okay, f of x is 3x minus 2. We're missing the 3 here.
Yeah, you're missing the 3.
Right,
it goes on the outside.
Disappears. Yeah. Yeah, I just when I write the numbers on this page, sometimes it disappears. So this is 3. Let's correct that. Yeah. Okay, so this would be 3x. There you go, not better. So now we can see that this would be 3x minus 2, this minus 2 and plus 2 cancel each other out, add to go to 1. So you see, it gets x again. It's exactly what we wanted to show. Again, let's go back to the property. Now we showed that g of f of x also is equal to x. So our conclusion would be that these two are inverse of each other. The answer is yes, they are inverse of each other, yes. But before I move on, I want to see a check mark in front of everyone's name if you all can follow the steps. Use the check mark in front of your name. If you can see how to verify whether two functions are inverse of each other using this method. You just find f of g of x, g of x, and it turns out to be x, has to be x exactly. And then if it is, then you can say yes, they are inverse of each other. I still need more check marks if you all follow this. Marlene, Oscar, Sinosha. Okay, again, Oscar, how about you? Are you okay? Oscar not responding. Okay, Oscar, it's the third time you're not responding when I'm asking you, so it looks like you're gone. You just logged in and you're not there. Okay, so let's take a look at actually how to find an inverse. So if I wanted to, let's say this is a different problem. Given y is equal to 3x minus 2, like f of x equal to 3x minus 2, find the inverse of that. F is the little symbol minus 1 on top of it, means they're inverse of each other. Or sometimes they show that f of x, and so they show it given, instead of that, they might say given f of x is equal to 3x minus 2, find the same thing they're asking, f of minus 2 of x. So that's all it means, is find the inverse of that. So anybody remember the method? You want to help me out here? Who remember the steps I showed you? The two steps involved. Check mark if you remember that. Who remembers the two steps to find the inverse? I'm looking for the check mark. Anyone remember it? You want to go back to that page, show you the steps I showed you earlier? And we'll go back to that page. Or if somebody want to grab a mic before I go to that page, you can do that. Do that. Bobby?
Everywhere you see y, you pencil x.
Okay, so you replace x with y, y with x. Is that what you mean? Okay, so everywhere I see y, I put x. Everywhere I see x, I put y. And then what do you do with the next step?
Solve for y.
Yeah, solve for y. Very simple. Solve for y. Actually, you can do it the other way. You can solve for y, and we can solve x in terms of y, and then replace exchange x and y. But it's better to do it this way. Step number 1 is to exchange the position of x and y. And then step number 2, solve for y. Okay, Bobby, when you solve for y, what do you get here?
X plus 2 equals 3y.
If I add 2, okay, and then how do you solve for y?
3.
Y both sides by 3. So what would y would be equal
X
to?
plus 2 over 3 equals y.
So that would be x plus 2 over 3 is equal to y. Isn't that what we have there? Yeah, same thing. That's a g of x there, right there. X plus 2 over 3. That's another way you can verify whether these are inverse of each other. You could start with g of x and find f of x the same way. You could replace x with y, y with x here, and then solve for y. You definitely would get y is equal to 3x minus 2. So that's how you would find the inverse. And the graph of this is interesting. The graph of the inverse function would have would look like this. Would be a mirror image of this this line here, y is equal to x. So if you look at these two functions, 2x plus, if I graph 2x plus 1, we should know how to graph a straight line by now. And if you graph x minus 1 over 2, then you would see these are a mirror image of this line here, x is equal to y. This is another fact about the two functions are inverse of each other with the mirror image of each other. And that makes sense because remember we said the position of x and y x would switch. Okay, remember for f, if I look at the f function here, you see the f function. Take a look at one point of f function that I'm showing you in pink. It is if x equal to 1, y is equal to 3, right? And then of course there are more points here. But if you look at its inverse function, look at that same point switch around, 3 and 1. So that's the behavior of inverse function. So 3 and 1 and 3, you see how their distance would be the same to this line x is equal to y. It just happened to behave that way. Another graph would look like this. So if this is f of x or g of x, if we use our graphing calculator and graph them, see the other mirror image of the same line. So this is how you find the inverse. So then another graph look like this. Again, see, this would be x squared plus 4. This would be square root of x minus 4. If you look at the graph of these are a mirror image of each other. So this would be a graph of the inverse function, but again, there are 2 steps involved to find the inverse. You replace x with y with x, and you solve for y, and then we can use this property here to verify also whether they are inverse of each other. So these are the stuff you need to know for inverse function, primarily for the next exam. Okay. So let's take a look at next concept here. Okay, we look at the exponential and logarithm. That's the next thing that we're gonna look at, and we're gonna look at how the graph of exponential looks like. So if you look at like these two graphs here, y is equal to 2 to the power of x, or g of x equal to 1/2 to the power of x. The difference between these two, as you see, the base here is greater than 1, and the base here is less than 1. So if you look at the graph of these, you can use our graphing calculator or just plug numbers like this. If x is equal to 0, like in this case, f of x would be 2 to the power of 0 is equal to 1. So for f function, if x is equal to 0, y is equal to 1, it's going to pass through this point here. So that's the other one. If x is equal to 0, y is equal to 1 here as well for g function. So both of them are going to pass us through point 0, 1. However, as I increase the value of x, f of x increases. You see how the f of x increases here is exponentially going up. But if I decrease the value of x, then f of x decreases. So that's how you see the behavior look like that. However, for the one that the base is less than 1, it would exactly behave opposite of that. As I increase the value of x, then g of x becomes 1/2 to the power of 1, 1/2 to the power of 2. So the number is going to decrease as it gets closer and closer to 0. However, as I decrease the value of x, so that would become -1. Remember, 1/2 to the power of -1. You flip the base, becomes 2 over 1. So then it would increases that way. So these are general graphs that you should remember. You can easily verify it just by looking at the tables. You can easily verify that. So these are the exponential function. Now, if you look at the logarithm that relate to exponential function, if you look at that, this is something that you have to remember. So let me write down the formula here, and everybody write it down on a piece of paper. Make sure you remember it for the exam. So if I have y is equal to log of x with the base b, you should be able to translate that into exponential function. Okay. So you see the base, this is the base of the logarithm, would be the same as the base of your exponential. So remember to start with that. The base of the logarithm would be base of the exponential. So b to the power of y is equal to x. Okay, there's some names correspond to this. So let's just read this definition here. If x and b are positive real numbers, such that b cannot be equal to 1, then y is equal to log of x with the base b is called the logarithm function with the base b. Okay, so if y is equal to log of x with the base b, this is the same as saying b to the power of y is equal to x. And note that the x, this is a name for that, it's called argument. This x here is just a name for it, it's called argument. So always would be equal to the argument here. So I'm going to label the argument x with the red color here. So the argument x, this argument could be expression, later you'll see. But the main thing you have to remember is if I give you y is equal to log of x, if there's no number here, it's understood that it's 10. If it's any other number, I'm going to indicate what that is. I'm going to call it b now. So I have to know how to change this logarithm to the one expression without logarithm, which is the exponential, as we looked at the graph of that earlier. So that would be the same as b to the power of y is equal to x. So without this translation, we really cannot solve any problem involving logarithm. That's the first thing that you have to remember. So write this down, everyone, and can you put a check mark in front of your name if you have this on the piece of paper, everyone, and you can start memorizing this one. Put a check mark. That's the first thing you have to do. If you don't have it, I'm not going to wait until you do put a check mark in front of your name, because they're not going to be able to move on with this concept unless you are willing to remember that y is equal to log of x to the base b is equal to b to the power of y is equal to x. You have to memorize this. Write it down 100 times on a piece of paper so you can remember that. Okay, so let's see who's here now. Leah, are you still there? I don't see check mark in front of your name. Marlene? Pinosha? I don't see a check mark. So I need you to put a check mark so I can confirm that you can remember this. Okay, I don't get any response from Leah or Leah, that's the rest of you are here now. Okay. Yeah, we get back to you later. But okay, this is what you need to know. Once you know this, the rest becomes pretty simple. We can go ahead and work with this logarithm problem. Okay, converting from logarithm form to exponential. That's the first thing you have to be able to do. Convert from logarithm to exponential. So knowing the formula is pretty simple. Okay, we just did a base. So like we have log of 32 is equal to 5 with the base 2. So this is my base of the logarithm. So that would be base of my exponential must be 2 then. To the power of 5 must be equal to the argument. Remember the argument is equal to 32. That's the argument. 32. Equal to 32. We'll go back to my definition again. You see that? Back to this. So you see how the argument here, log of x, everything is equal to the argument, everything is equal to the 32. Okay, so this is how you convert. You should be able to convert that first. So in this case, it's another example. Rewrite the logarithm equation to exponentials. There we have it. So the base of the logarithm is 10. So it would be 10 to the power of negative 3 is equal to the argument. The argument is 1 over 1,000. And that makes sense. 10 to the power minus 3 is equal to 1 over 1,000, right? Another one. Log of 1 is equal to 0 base 5. So it means the base of logarithm, this is 5, to the power of 0 is equal to the argument 1. That makes sense. Anything to the power of 0 is equal to 1. That makes sense. Okay, I'm going to pause the session for a second. I want you to quickly rewrite these logarithm equation to the exponential now and put a check mark. Okay, those of you viewing this session, I encourage you to pause the session at this point and continue, see if you were right. Alright, looks like most of you are done with this. Great. So can somebody quickly tell me how do you change this first one, number 1, to the exponential? Log of 9 is equal to 2 with the base 3. Okay, who wants to go with that? Grab your mic, please.
You take the base, and then you take the equal sign to put it to the power exponent. So you have 3 to the power of 2, which is equals to 9.
Sure. I'm going to continue with the rest of them. Next
Okay.
one.
So you just take 10 to the power. I don't know if that's negative 2 or 2. I can't see it.
Negative 2.
Okay, I would assume it's negative 2 because it's a fraction. But okay, it's equal to 1 over 100.
Yeah, it should make sense. So all this means exactly 3 squares 9, 10 to the power minus is equal to that, 1 over 100. Next one.
And you just take the base, which is 8, which is the power of 0, and equals to 1.
Everything to the power of 0 is equal to 1. So that definitely makes sense. So that's the first thing you do, be able to make that conversion there. So here it says evaluate. Very good. Evaluate the logarithm here. To evaluate this, you just write y is equal to log of 64 with the base 8. That's what we want to know what y is. So let's go to something like y, and then you convert this to its exponential. So again, base 8 to the power of y is equal to 64, and you just solve for y. That's what we have here. Now you can easily change 84 to 8. You want to make the base the same, or exponent the same. In this case, we can make the base the same. So 64, I'm going to write as 8 to the power of 2, so y must be equal to 2. So this is equal to 2. Simple as that. Once you change it into the exponential function, we can easily see what the missing number would be in this case. So let's take a look at another example here. So again, we're going to know what that is. I'm going to write this as y is equal to log of 1 over 125 with the base 5. So if I change this to the exponential, 5 to the power of y, so 5 to the power of y must be equal to the argument, which is right here. So in this case, I'm going to make everything the base 5. So 125 is the same as 5 cubed And then if I move it to the top of the fraction, it becomes 5 to the power minus 3, so y must be equal to minus 3. So this would be equal to minus 3. But before I move on to the next example, I want to make sure we do okay with this. Can I see a check mark for every name? If you can follow what we're doing here. If you have a question, now is a good time to bring it up.
I just have a quick question about
yes, Jim.
Are we taking a break today?
Yeah, we're going to take a break in a few minutes, actually. I just want to do a lot of stuff I have to cover, so we're going to have a little shorter break today.
Okay.
So, yeah, we'll go over the break in a moment. But are we okay with this? We're good, everyone? Yeah, I know we're due for a break right now. So let me go over one more. Here you go. It's another example. So here we have y is equal to log of 1 over 8 to the base 1/2. So you have 1/2 the base to the power of y is equal to 1 over 8. You're going to make the base the same. So 1/8 could be 1/2 cubed. So that's how you can solve for if the base is the same, the exponents are the same. So this is what I'm going to do. I'm going to go ahead and put up these examples, 3 examples here for you to evaluate. However, we're going to take our first break today. Let's say we'll be back by 11:30. So let's say we'll be back. We'll be back at 11:30 a.m. Okay, but these are the 3 examples we're going to go over. If you like to, while you're taking a break, you can evaluate these 3 examples, so we can move on quickly right after you're back from the break. So I'll go ahead and pause the session and see you after the break. Okay, we're back. Let's quickly evaluate these. Anybody with the mic wants to try the first one, please?
Can y equals to 1,000?
Okay, so that's why y is equal to log of 1,000 with the base 10. So now we need to rewrite this in the exponential function. And how do you do that? Go ahead.
Can y equals to 1,000?
Yeah, 10 to the power of y is equal to the argument 1,000. We can make the base the same. So this would be 10 to the power of 3 is equal to 10 to the power of y. So y must be equal to 3. Is that what you mean, Jared? Okay, someone else, please start the next one. All right, Bobby, you want to try the next one, number 5?
Is it go down to 4y?
Okay, let's start with y is equal to this, right?
Log 116 base 4.
So you write 4 to the power of
y.
Y is equal to 1 over 16. Okay, now what do you do next? So you want to make everything to the base 4, right?
Yeah. So
that would be
4. It'd be 4 squared.
4 squared.
1 over 4 squared.
Right. So how would I bring this up? If I bring this up, that becomes what? 4 to the power of what?
2.
Negative 2, right?
Sorry, negative. Yeah.
So y must be equal to negative 2.
Yeah, no, like it's true. Like I can't make
Very
my
good.
arm straight.
Okay, let's give the mic back to someone else. Caitlin, still, are you able to talk today? Do you have your mic? No? Okay, you don't have your microphone. How about you, Eddie? Eddie, do you have your mic today? Not right now. Okay. Jerry, how about you? Okay, you guys need to set up your mic so you can communicate. Pauline, you want to try it? Go ahead.
Y equals log 3 with a base of 1/3.
Okay, and then what do you do next?
Then 1/3 to the power of y equals 3.
Okay, let me write down the formula here. So remember, y log of x, you write the base of logarithm has to be the base of the exponential to the power of y is equal to the argument. That's how it is. So you want to tell me now?
You wrote it 3. You wrote it wrong.
Okay, I wrote wrong. Okay.
The question says log with the base of 1/3.
Oh yes, you're right. The actual problem is not really properly. Thank you. Okay, that would be log of 3 with the base of 1/3. You're absolutely right. So you were right in the first place. So go on, please. It would be the base 1/3 to the power of
y equals 3.
Good. So how do you make the base the same?
3 to the power, or the answer is -1.
Right, so this is 3 to the power of 1, we move it up, becomes 3 to the power of -1. And then that would be 3. So 3 to the power of -y is equal to 3 to the power of 1. So yes, -1, y is equal to 1, so y is equal to -1, basically. Alright, so this will be equal to -1. This would be equal to -2. And this would be equal to 3. Like that. So we can use this conversion here to evaluate these. Now, let's take a look at this one here. This is something that you want to memorize it if you can. If you have log of b with the base b. Now, if I write this as y is equal to log of b with the base b, and go through the calculation, the b to the power of y is equal to b. So you see that y must be equal to 1. So if the log of the when the base of the logarithm and the argument is the same, this would be always equal to 1. That's something that you can remember and use it to reduce or simplify. That's one thing that we can remember. So this one here, we can just quickly, if you remember the property, because of the log, the base of the logarithm and this base of this argument is the same, so the whole thing must be equal to 7. So you don't really have to do anything if you don't want to. Or you can write it like we did, y is equal to, if you forget this, you can always write it down as this, and start from scratch. The base of the logarithm to the power of y is equal to the argument, so y must be equal to 1. Okay, this would be another example here. You see how if I change this to 3 to the power of 1/4, you see how the base of the logarithm and the base of the argument is the same, so the whole thing must be equal to 1/4 without doing any calculation. But you can go through the conversion and verify that. But before I move on, I want to make sure you understand this concept. Can I see a check mark under your name if you're really okay with this? Okay. So if I wanted to evaluate log of 100,000, so you just write y is equal to log of 100,000. Because there's no base here, it means it's base 10. So it would be 10 to the power of y is equal to 100,000. You can easily make this the same base. It would be 10 to the power of 5, so y must be equal to 5. So this whole thing is equal to 5. Just by converting that, we can verify all that. So another example here. You let y be equal to log of 0.01. Again, the base is 10. It's not there. So 10 to the power of y is equal to the argument here. This is the same as 10 to the power of -2. So y must be equal to -2. Question, anyone? You can always use your calculator to find the approximate value for these logarithms. Just enter the number 420, and then you enter the function log or log. Then you can.
Caitlin asked if you could go back, Professor.
Sure. Thank you. Going back to this one. This one? Okay. So let me pause here. Okay, 10. The question is, where did 10 come from? So if there is no base written, it's understood to be 10 always. Okay? If it's not 10, then they have to tell you what it is. Okay, the graph of this logarithm will be similar to the graph of the exponential because, as you see, they're the same. You can convert the logarithm to the exponential, and we already looked at the graph of exponential. Like this case here, if you want to graph y is equal to log of x with the base 2, this is really, it's the same as y is equal to 2 to the power of x. So if you graph this, that would be the graph of the logarithm, as we can enter the numbers, and as you see, the graph of the log would look like this. It looks kind of very much like that graph of exponential that we looked at. So if you look at y is equal to 1/4 to the power of x, or y is equal to log of x with the base 1/4, is the same. You just plug the numbers. We can graph these. The basic graph of the log and exponential is good to know. So as you see, we looked at this before. If you substitute some numbers for x and y, you can verify that if b is positive, here, the graph, the exponential graph, would behave this way. If it's between 0 and 1, would behave this way, and so as the graph of the logarithm. So we can easily verify these graphs by simply look at some numbers. And the range and domain of these, the domain would be all the number from negative infinity to positive infinity for exponential function, and the range is from 0 to infinity. And then you can easily again verify that if you look at the exponential function, you can see the graph, because this goes from all the way from left to right, covers all the x. So that's how you can verify that the domain would be all real numbers here, so just cover everything on the x-axis. However, the range, if you look at the range, it becomes 0 all the way to infinity, because the range would be these numbers here, all the way from 0, range would be the value of y, going all the way up. And this is the exact opposite of that. Okay. So once you look at the graph, you can easily see this. And you can see these in your summary of your chapters to remember which is which. Now find the domain of the function. So what you need to do is, for the logarithm, you want to make sure that whatever you have here inside this parenthesis would be positive. So we say 4 minus x greater than 0. So in this case, you solve for x. X would be less than 4. So the domain would be all the values from negative infinity to 4. So what you do to find the domain, again, you take whatever you have inside the parentheses. You say this must be positive, greater than 0. You solve for x. So in this case, all the number greater than minus 3, that would be the domain. Now, one classic word problem that you would see for using logarithm is applying a common logarithm to compute pH. pH is hydrogen potential of a solution. Is defined as minus log of h squared, where h means h plus h. That's the symbol they use. That represents the concentration of the hydrogen ion in moles per liter. So the pH ranges usually from 0 to 14, and the midpoint is 7. So when the midpoint is 7, and when the pH is equal to 7, that represents a neutral solution. The value is below 7. That would be the solution would be more acidic, and if it's above 7, that would be more alkaline. So these are just based on the equation pH is equal to minus log of h plus. Then you can find out how acidic is the solution going to be. So let's take a look at some example here. You want to find the pH in this case where they're given to you h plus is equal to 1 times 10 to the power minus 1. Okay, so we only really care about the value of h plus, the concentration of hydrogen. That's what you look for. And then if all you do is just plug it into this formula and then use your calculator basically. And then some of them you can actually evaluate. In this case, you can easily evaluate that because one of the property we learned, the log of d to the power of b to the power of a. Remember we said if the base of the logarithm, the base of the exponential is equal to a. That's what we really can use here. Because here you have log of 10 to the power of minus 11. Because there's no number here, it means the base is also 10. Okay. So this would be, the base must be equal to 10 there. So there's no number here. So this would be minus 11. So this whole thing must be equal to minus 11. Okay, and then you have a minus front of that, so the whole thing, the pH would be equal to 11. So don't get intimidated with these word pH word problems. Just all you have to do is just substitute whatever value they're giving you into this formula and then use your calculator to solve for it. That's all you have to do. There's no calculation involved with this, except some of these you need to use some of the properties that we learned for this section. It's pretty simple. Okay, so let's take a look at some of these property of logarithm. You can verify all these, but these are the ones that you should be able to remember it. So log of 1 is equal to 0. Well, remember we can verify every one of these. Y is equal to log of b, log of 1 with the base b. If I rewrite this in exponential, this is the same as b to the power of y is equal to 1. So you can see that anything to the power of 0 is equal to 1, so y must be equal to 0. So everywhere you see log of 1 with any base must be equal to 0. Now the second one, you can also verify the second one. We talked about that before. If the base of the logarithm is the same as the base of the exponential here, the whole thing would be equal to this exponent here. So there's no number, there must be 1. This is equal to 1. And if this is p, the number 3, then that would be equal to p. And next one here, we have number 4. We have b to the power of log of x. Again, if the base of the exponential and base of the logarithm are the same in either way, the whole thing would be equal to this number x. Again, we can verify that by letting this equal to y. You can easily verify number 4 as well, because this would be the same as saying b to the power of x is equal to that number. Well, just select from that right here. This term here, remember the base here is 10. The base is b actually in this case, the same as base of the logarithm. So this would be b to the power log of b to the power of x. All this stuff here must be equal to log of x. So that's why it turns out to be x. So in general, if you want to remember these two properties, if I have a to the power of log of a to the power of x, or x to the power of log of, let's just use the same variable here for the base. So the base is a. Either way would be equal to x. Okay, so then the base of the logarithm, the base of this exponential, or base of the logarithm and base of the exponential are equal to each other, the whole thing would be equal to x. So this is a very handy formula that you can use to simplify expressions very quickly. So these are the good properties to remember. So just you write it down, the paper, to remember that. So let's take a look at the examples here. Okay, these are very, very important properties that you need to remember. We'll start here. Okay, we already talked about some of these. Log of 1 is equal to 0. If the base or the sum is equal to 1, that's what these two we talked about. And then we already talked about this one as well, and this one. Now, number 5, if I have a log of x times y, this is the same as log of x plus log of y. Base has to be the same for all of them. Let's see here. Okay. Now if I have log of x over y, this would be log of x minus log of y. You must write these properties down on the piece of paper and make sure you remember all of these. The next one is you have to have log of x to the power of p. You can take this p and place it right in front of this logarithm. That will be the same as p times log of x. We're going to use this for solving equations in the same base, of course. So these are the ones that you have to remember. Alright, so let's summarize all the formulas that you need to remember for this section. I'm going to write it down here in this corner here. Okay. The very first one that you have to remember is if I have y is equal to log of x with the base b, that is the same as b to the power of y is equal to x. First one you have to remember. How to convert from exponential to logarithm or logarithm to exponential. The next one we're learning right here is log of 1 is equal to 0 with the base b, or log of b with the base b is equal to 1. And any combination of those. If I have log of b to the power of, so this is 1 here, b with the base b, that would be equal to p, or the other way around, if I have b to the power of log of x with the same base b, that also would be equal to x. The next three that we just learned, log of x, y is equal to log of x plus log of y, same base. Log of x over y is equal to log of x minus log of y, same base, b. And the last one is if I have t log of x to the base b, that would be equal to, that t can go to the top of the fraction right here. So let me write in the bottom here. We already have it here. That's the last one, it's just going to get. Okay, I want to see if you guys can put a check mark out of your name and let me know if you have all this in one page. You may need to make a flashcard out of these. Put a check mark if you have all this in one place. I need you to memorize all of these. And if you need to make a flashcard to memorize any of these, please do so, because if you don't know these, you won't be able to do a lot of problems that we're going to do now. So check marks if you all have them in one place, because we're going to refer to these now for the rest of the problem. So you need to know all these properties. Okay, Bobby, are you there? Jared, are you there? Jim? Samantha?
Yeah, I'm here.
Okay. Just put a check mark in one front of your name if you're there. Okay. So you need to know all these in order to proceed with these examples. So let's take a look at some examples here where we use these properties. Okay, this is a good one. You should be able to write the expression as a sum or difference of logarithm. So what we need to do, we need to pretty much expand this, basically. So in order to do this, we have to use those properties. The first property that we're going to use is this one here. You said that log of, okay, we'll start from number 1. Step 1. Log of x over y is equal to log of x minus log of y. Again, the base has to be the same. So in this case, your x would be the stuff at the top of the fraction, your y would be the stuff at the bottom of the fraction. This would be the same as log of what you have at the top of the fraction minus log of what you have at the bottom of the fraction. That's how you start with, using this property here. The next one here is, looks like using the second property where you add them. So in this case, you get log of, for the second part, you use log of x times y. That's the same as log of x plus log of y, with the same base b again. So you see how we have x times y cubed? That's why we write this log of x plus log of y cubed with the same base 3. And this one I'm going to move, if I have log of x to the power of n, I can move that n right front of that. So this 2 here can go right front of these, like we have here. 2 log of z, and this 3 can go right front of this. 3 log of y, and just log of x. So any questions as how to expand this, first of all? Can I see a check off on the beginning? You're going to see one problem like this on the exam where you have to use this property to expand them. Write it as sum or difference of the logarithm. Check mark if you follow this. If not, we can talk about this before we go to the next example. Question, anyone? Margarita, do you follow what we're doing so far? Check mark, please. Leah? Jerry? Okay, Leah, are you there? Okay, so it looks like we're really okay with that. So let's take a look at another example here. Okay, this is another example where we want to expand them. So this would be log of x over y, the same as log of x minus log of y. All the bits are the same. So this is your x at the top, this is your y. So that's why we have log of what you have at the top minus log of what you have at the bottom. That's the first thing we do. Next thing is to write this as x plus y to the power 1/2. So you would get n. Next property would be, if I have log of x to the power of n, the same as n log of x. N can go right in front of this. So this 1/2 goes right in front of this. So it will be 1/2 log of x plus y minus. This is the same. That's why it's equal to 1. Question? Ivan?
So where does the 1/2 come from?
1/2 because come from this. When I have square root of a to the power of m, if I have n root of that, if I write this in exponential, so that's the same as a to the power of m over n. Make sure you write this down somewhere. Remember this when we talked about radicals? Yes. Okay, so that's where that comes from. So in this case, your a is x plus y, and your 2, because there's no number there, your n is 2 because it's understood as 2. This is 1 because there's no exponent. So that's why this would be x plus y to the power of m over n would be 1/2. So you see where that 1/2 come from now?
Yeah, now I get it. Thank you.
Okay, good. Sure. Any other question, anyone so far? Alright. So that's how you expand them. Now this one here, another one. So in this case, we will write this as log of all this stuff here to the power of 1/5 for same reasons. Yeah, this is 5th. Again, this comes from square root of. Question someone. Go on, who are the questions? Okay, no. Again, this would be x to the power of that. Okay, question? I'm going to grab your mic and talk.
There's a question in the chat box for the last one we did.
I didn't get you, Margarita. What did you say?
There's a question in the chat box. What the last one we did?
This is what happened to 10.
Right.
You mean the previous one, this one here?
I think so.
Oh, I see. Okay. Well, this one here would be log of 10, because the base is 10 when we don't write it. Remember, the exponent here is 1. Then the base and the exponents in the base of the logarithm and base of the exponents are the same. You have one property, this whole thing would be equal to the exponent 1. That's why you get 1 here. You see that? This is one of these properties that we listed up here. The summary, this one right there. This one, we did this one. Right, with the base of, you got it, we said, alright, good. Which looks like you're okay with that. Okay, so back to this one. So in this case, this would be to the power of 1/5. We can bring this 1/5 right up front because of the property we have. Log of x to the power of n is equal to x times log, n times log of x. Give the base must be the same. So that's why this would be 1/5 log of all that. Good question, anyone? Okay. So we will take that. You should be able to do this the other way around. If I have this in expanded form, you should be able to write it in one single logarithm form. Then you just have to work this backwards. So in this case, this 2 goes on top of this. Again, the property we learned is log of x to the power of n is the same as n log of x. So this n can go here or go there. In this case, so you would put this right on top of the x. So as 1/2. So as 3. So once we do that, we'll see we get one step closer to putting this together. Now these two, you can combine them by using the property we learned, log of x plus log of y. That would be the same as log of xy, with the base being the same, all of them. So in this case, the base are the 10, so we can take this one and combine them into one logarithm. Now, from here to here, we use the fact that log of x minus log of y is the same as log of x over y. Again, the base are the same. That's what we're doing here. We just, because of this subtraction, we write it right on top of each other like that. And then we can write as y is about 1/2 as y squared. That's what we get. So once again, can I see a check mark under your name if you're all okay with what we're doing? So if you have the terms adding or subtracting each other, you can write in the single logarithm. If you look at the sample test, there's a couple of problems like this where you have to do this back and forth, and definitely going to see something like that for the next exam. Make sure you review that. Any questions so far? Question, anyone? Okay, one other thing that you need to know for the next exam is how to solve equations involving logarithm. Let's take a look at some of these, like this one here. Solve the equation. So for this type of problems, you can use the basic definition of the logarithm. If I have log of x is equal to y with the base b, we learn how to change this to the exponential. That's the same as b to the power of y is equal to x. So basically what we're doing here, so in this case, when we have a log of 2x plus 5 is equal to 1 with the base 3, I can rewrite this as 3 to the power of 1, the base to the power of 1 is equal to 2x plus 5. So we change this into exponential, so you get a linear equation out of that. That's what we get, 2x plus 5 is equal to 3, and then basically you solve for x. You should check the answer for all these, make sure they're okay. Alright, then you see a check mark under your name if you can follow this example here, because these are like really important problems that you need to know. Check mark if you have any questions. I want to give you one problem like that right now for you to do on your own, knowing all this property now. Okay, let's see. Ray, are you okay? Nocha? Tanisha? Yoli, you must be late. Yoli, are you okay with this problem? Looks okay. Okay, who else? Okay, let's put your response being good. Alright, let's take a look at this example here. I want to give you a minute to solve for x using this property. And again, those of you viewing this session, it's a good time to pause the session yourself and work this out and see if you get the same answer. For the rest of you, I'll do the same. I will pause the session for a moment. And when you're done with solving for x here, I want you to put a check mark under your name so we can continue this together. Alright, could you place a check mark under your name? I see some of you already done that. Okay, who wants to go over this problem? Marina, you said you've done this. You want to go ahead and
Yeah, I can do it.
go over that? Good, sure. What do you do first?
So first you need to make it into the exponential form, which would be 6 squared equals 5x minus 4.
Okay. So 6, the base of the logarithm, is equal to the power of 2, is equal to the argument. Very good. Okay, so how do you solve for x?
6 squared is 36, equals 5x minus 4. Add 4 to both sides. Then you get 5x equals 40, or 40 equals 5x, sorry.
5x equals to 40, or 40 is equal to 5x, that's fine. So how do you solve for x?
5 by 5, x is 8. And then I checked it by plugging the 8 back into the linear equation. So it's 5 times 8 minus 4 equals 36. 40 minus 4 equals 36, and 36 equals 36.
So that works.
So it works.
Log of 36, 36, and definitely that's true. 6 plus 2 is equal to 36. Very good. So let's take a look at another example here. So in this example here we have log of x to the base 4 to the left hand side, and then the right hand side we have 1 minus log of x minus 3 with the same base. So with this one, we just move all the terms with the log in one side of the equation. So subtracting minus log of x minus 3 from both sides of the equation. So you get to this form here. So now we have a property here to combine these two. So if we recall, log of x plus log of y is equal to log of xy. And the base are the same. That's exactly what we're doing. This is your x, and this is your y. So that would be xy right there. Then once we get to this form, then we're going to write this in exponential. It would be, we can of course distribute this first. Distribute it to this point, and then get 4 to the power of 1 plus equal to the argument here. That's why we get x squared minus 3x equal to 4. Move everything to one side of the equation. either we can factor this and we find x equal to 4 and x equal to minus 1. And don't forget you need to check the answer for both of these. So if you do that, you'll see that notice that x is equal to minus 1 is not a solution. That's not going to work. If you plug it back, however, the 4 it does. So the only answer would be 4. Okay, can I see a check mark in front of your name if you're okay with this before I give you an example like this for you to do on your own? So remember what we did. We combined them together using the property, change it to the exponential, and then we solve for it. Okay, so check mark in front of most of you. Marina, are you okay with this? Jared, are you okay with this?
Hold on, I'm writing it down.
Sure. Okay. Tell me if you don't follow any of the steps, anyone. Jared, you okay? Need more time?
Yeah, I just finished.
Finish, okay. So you follow it? Follow the rest of the steps here. Okay, let's try this. I'm going to give you a minute to work this out. It's very similar. You're going to move all the log to one side of the equation, and then change it to exponential and solve for x. Once again, those of you viewing this session, go ahead and pause the session at this point, see if you can get the answer. And the rest of you online, do the same. And put a check mark in front of your name so I know you're done. Then we'll look at it together. Okay, looks like some of you are done with this one. Let's see, Margarita, you done? Marina, Marlene, you done? Marlene, do you have your microphone?
Yes.
Okay, you want to go ahead and tell me how to start this? Bobby, did you have a question?
No. I think I can do it.
Okay, sure. Go ahead. What's the first step?
The first step is to get the log, both of them on one side.
Okay, so which way you want to move them?
Add log yeah.
Log of x.
I will really but
Okay, so let's do that. So we get log of x minus 8 plus log of x is equal to 2, the base of x. So what will be your next step? How do you combine it?
Log can you put the x in the front or no?
No, this one, let me write down the formula so you can remember. Log of x plus log of y. That's the same as log of xy. Do you remember that?
Yeah.
Okay, so how do you write this now?
X squared minus 8x.
How about x times x minus x? So we have to multiply these two together, right? Yeah, you get, yes.
Right.
Once you distribute it, you get that. You're right. Okay, but before we do that, we need to, what's the next step?
I don't know. What I did was wrong, I guess.
So let's go back to the previous example. Remember, we had this one here. So that's exactly what we're doing here. Right after we get it to this point here, okay, in the sample example, what are we doing here? You're writing the exponential and logarithm. Log of x with the base b is equal to y. We change it to the exponential. B to the power of y is equal to x. That's what we're doing. So b base to the power of 1 is equal to the argument. So that's exactly what we need to do here after this step. Okay, how do you convert this into exponential?
3 to the power of 2.
Right. 3 to the power of 2 is equal to what?
2.
The argument,
X.
right? All the stuff.
Mm-hmm.
So 9 is equal to x squared minus 8x. So what do we do next?
Subtract 9
Okay, so
from both
subtract
sides.
do that. So we get 0 is equal to x squared minus 8x minus 9. So we have to solve this for x. Is this factorable?
Yeah.
Okay, how do you factor?
X minus 9, x plus 1.
Okay, so we get two answers, x is equal to 9 or x equal to minus 1. We need to check both of these answers in here so it makes sense, like we did with the other one. You see how one of them didn't work? So you always have to check your answer. I'll let you do that. Okay, can I see a check mark in front of your name, everyone, if you all follow this type of problem? Once again, you need to combine. You need to combine the logarithm using the property, and then use the log of x is equal to y with the base b, be able to change it to b to the power of y is equal to x. Okay. And don't forget to check the answer, by the way. Now, just another example here. Solve the equation. So the base is 10. That's why we don't have it here. So it will be 10 to the power of 3.7 is equal to the argument here. Then we just simply solve for x. You can use a calculator for this type. Okay. So you can check the answer also using your calculator, which is okay. So basically, then we get it to this point here, then we get the log of x is equal to log of y with the same base b. We conclude that x must be equal to y. Okay, assuming that x is greater than 0, y is greater than 0, b is greater than 0, and b cannot be equal to 1, of course. Now, this would be a good example here. Now, when you have a natural log or logarithm, all the properties that we learned would be exactly the same, except the base for the natural log is e, the constant number. So when we said log of x times y is equal to log of x plus log of y with the same base b. That would be the same as ln, natural log of xy, is equal to ln of x plus ln of y. The only thing is the base here is e.
Professor, Eddie asked if you could go back.
Okay, sure. Thank you for letting me know. No problem. Back to this problem here, or this one? Which one is it? This one?
Think the other one.
No, the other one. This one, I think. This one here? Yes. Okay, sure. So here we have log of x plus 300 with the base 10. If you're converting this into exponential, so we get 10 to the power of 3.7 must equal to the argument. So we're doing. And then we are solving for x. Again, you have to use a calculator to evaluate 10 to the power of 3.4. So you insert in your calculator 10, and then depending what calculator you have, sometimes you have a function called x to the power of y, or y to the power of x, depending on what calculator you have. And then you can insert 3.7, and you can insert equal sign, and that's how you get the number. And then you subtract 300 from that, you get this number. Okay.
How would you do that without the calculator?
Well, you can. You have to use a calculator for calculations like this. You have to use a calculator for this kind of calculation. So we're going to take a look at next example that we were working on. I think this was this one here. Okay, so we were saying that all the properties that we learned would be the same. So if you remember, I had log of, let's use a different color here, separate that. If I have log of x over y, that would be log of x minus log of y with the same base b. So that would be the same as for the natural log. So that would be natural log of x over y is equal to natural log of x minus natural log of y. Okay, remember we had this property here, log of x to the power of n is equal to n log of x. That would be the same for the natural log. So pretty much all the one that we did works the same. So in this case, as we see, the steps would be the same. So for this one, to combine these two, because we have natural log of x plus natural log of y, we can change it to 1, combine them into x times y. And then once you combine them, then again, because if log of x is equal to log of y, they have the same base. Concludes from here that x is equal to y. Same as here, natural log of x is equal to natural log of y. Then we can conclude from there that x is equal to y. The same thing here. So we just see that all this stuff here must be equal to this if the logs are the same. So this is how you get into the equation. You solve for them this way. Okay. Well, let's see if you can do this on your own. Once again, those of you viewing this later, I encourage you to pause the session at this point. The rest of you doing this live, put a check mark in front of your name, please, when you are done with this one. Okay. Looks like most of you are done with this. Who wants to go over this problem with me? Oscar, do you have a mic? Jim, how about you? Yes, Jim, go ahead. What's the first step?
Well, the first step I did was put t minus 3 and t minus 1 and multiply together. So it'll be ln parentheses t minus 3 parentheses close parentheses open parentheses t minus 1 close parentheses.
So, okay, somehow your mic was really low. Can you talk closer to your microphone? So you're saying that log of x plus log of y is equal to log of x times y.
Yes.
That's what you're saying, right?
Sorry.
Okay, so this would be natural log of t minus 3 times t minus 1 is equal to natural log of 2t minus 5. Combine it together, right?
And then
So what's the next step?
and then you I don't know what you call it. I guess you distribute it.
Okay, we can distribute, but so from here, if natural log of x is equal to natural log of y, we can conclude from here that x is equal to y. So right here, we can go ahead and show that t minus 3 times t minus 1 must be equal to 2t minus 5. So we don't have that natural log there anymore, so we can solve for t.
Right. Okay.
So now we can distribute. We get t squared
Where minus t
minus t
minus 3t plus 3.
plus 3. And then we can
And you take 2t minus 5. You minus that on 1.
combine these two. It would be t squared. This would be 4 minus 4t. And then you have 2t. Can subtract that because it's minus 6t. Is that right? And then here we can add 5. And you have plus 5. That would be 8 plus 8. Is that factorable? Sure is. This would be. If it's not factorable after this, you can use quadratic formula like I showed you last time. So what combination are you going to use here?
4, negative 4 and 2. Negative 4 and negative 2.
4 and 2. Then you want to get minus for both. So t is equal to 2 or t is equal to 4. Again, you have to check the answer, make sure these are working like we did with the other ones. Alright, thank you. Alrighty, so that's how you solve this kind of problem. Now, another type is when the bases are the same, the exponents are the same. So this would be another fact that can make the base the same, then we can conclude from there the exponents are the same. So the example for this would be this one here. So how we have 4 to the power of 2x minus 9, and then here we have 64. The question is, can I make these two bases the same? Well, in this case, I can make 64 with the base of 4, so it will be 4 to the power of 3. So it's 4 to the power of 3 is equal to 4 to the power of 2x minus 9. We can conclude from here that when the bases are the same, the exponents must be the same. So from there, you can solve for x, and then that's how you can do this. So let me make sure we understand this other concept here. Check mark if you can follow this space. Any question?
Can you explain that over again? I'm a bit confused.
So this one right here, the one example 5.
Yeah.
Also, I see Oscar had a question earlier. And then let me see. So Notion says, how do the 4s cancel out? Are you talking about this problem here, Notion? So there's no s here. There is no 4s. Let's go over this. Looks like there's some confusion here. All right. So in this case, we're saying that if I have, this is the concept here, if b to the power of x equal to b to the power of y, x must be equal to y. That's what we're saying. So the question is, if b to the power of x equal to b to the power of y, we can conclude from here that x must be equal to y. So the question is, can I make the base equal each other? Here I have 4 to the power of 2x minus 9 equal to 64. But I can make the base equal each other because 64 is 4 cubed. So 4 to the power of 2x minus 9 is equal to 4 cubed. So again, if the base are the same, so the base are the same, e here, b here, and the base are the same. In this case, the base here is 4, then the exponents must be the same. If the base are the same, conclude from there the exponents must be the same. So all these must be equal to other here, just to make it the same. So that's why we get 2x minus 9 must be equal to 3. So do you follow that now? Oscar, you said await the answer, question mark. Are you talking about this one or the one with the previous one? Okay, so let's just say yes, got it. Okay, good. Alright, Oscar is good too. Alright. So everybody okay up to this point? Can you see a check mark from the one's name? If you're all okay? It's pretty simple. If you can make the base the same, the exponents must be the same. All we're talking about here. Okay. Alright, so let's take a look at one question. Oscar. Now for the last one, you just have to check both of those into the original equation and see which one makes sense. You have to check both of them. Okay? Anytime you get the answer, you need to check it. Alright. So let's take a look at another example here. So it's similar to the one that you can make the base the same. Once again, I'm going to pause the session. Those of you viewing this recorded session, let's go ahead and pause at this point, see if you can get this answer, and then continue. The rest of you, you can check mark for the name. Once you're done with this one, you clear your check marks now. Alright, we have 2 minutes to solve for x. Okay, let's other people who haven't participate do so. Let's see who wants to do that. Okay, Sunosha, are you there? You have your mic today? You haven't finished. You get 2/3. Okay. But I'm more concerned about the steps, so because if other people view this, you can see what we're doing. Yoli, David, how about you? You want to go ahead and tell me the steps? You have your mic today? I'd like you to go over the steps. Okay, let's see who wants to go ahead and tell me. So again, I want someone with the mic to go over the steps. When I record this, when I edit these, people cannot see the one that you're typing. So who wants to grab a mic and go over this?
I can do it.
Okay, Marina, go ahead, please.
Okay, so first I made 8 into a base of 2, so 2 to the power of 3.
Okay, so we can make the base the same, because 8 would be 2 to the power of 3, so if the base the same, the exponents must be the same, right? So you get 3x plus 1 equal to 3, and then what do you do next?
Solve it normally, so subtract 1 from each side. 3x minus equals 2. Divide by 3, 2 over 3. And then...
So, yeah, you were right, so Russia was right 2/3, but that's how you go over the steps. Very good. Alright, thank you.
You're welcome.
So let's take a look at the next example. Okay, this would be another example. Solve where we need to make the base the same. So in this case, here we have 1 over 4, and the base here is 2. So on the left hand side, I have 2 to the power of x to the power of x plus 3. On the right hand side, I can make this 2 to the power of 1 over 2 power of 2. Then you say I can move this 2 to the top of the fraction and make it 2 to the power of minus 2. So you see how I made the base the same again? The base here is 2, the base here is 2. So now I can make the exponents the same as each other right there. And that's exactly what we're doing here. We're saying that if I distribute this, this would be x squared plus 3x must be equal to -2. And then we write this in the standard form, we factor it, and we find the solution set. And don't forget to check the answer for all these to make sure they're correct. So let's go ahead and do this one on your own quickly. Everyone, give you a minute to work on this. Again, those of you viewing the recorded session, this would be a good time to pause the session to see what you get first. Okay, who wants to go over this quickly? This is fairly simple example. All right, anybody with the good mic, grab the mic, please. So this is some concern here from few of you. You thought the last problem I got over too fast, is that why? Okay, Kathleen, still you asked me to go back. You mean talking about the previous one, right? So let's go back. Are you referring to this problem here? Okay, so she says yes. Alright, Kathy says no. Okay, now this was the, well, let's go over this very quickly. Well, slowly now. And then we'll look at the one that most of you completed. Okay, over here, the goal here is to make the base the same. So you see how the base here is 8 for the right hand side, and the base here is 2 for the left hand side. So the goal is to make the base the same. I can make 8 look like 2 if I write it as 2 to the power of 3. Then the base will be the same here. So let's see. So Nusha, do you follow that now? I mean, is that what part you don't understand? Do you get it now so far? Do you see what we're doing? Okay. So
I think we want to see the example number 6, I think.
Okay, so let me make sure that she's not talking about this one. Are you talking about this one here? Yes, she says yes. Okay. So after that, you see how we get, oh, I see what you mean. So this one here would be 1/4. On the right hand side, we have 1/4. On the left hand side is 2. I can make 4 look like 2 if I write this as 1/2 squared. And then if I move the 2 up, remember, if I move 2 to the power of 2 up, it becomes minus. Or if it's minus at the top, I can move it down, it becomes plus. So that's how we get 1/4, which is 1/2 squared, the same as 2 to the power of minus 2/1, which is 2 to the power of minus 2. You follow that? You follow that so far? Yes, okay. So now we managed to make the base the same. You see how we have 2 here on the left hand side, 2 the right hand side. So if the base are the same, so the exponents must be the same. So x times x plus 3, which is x squared plus 3x, must be equal to -2. So are we okay up to this point? So are you okay up to this point? Okay, now the question is, does 3 becomes 3x because the exponents got distributed? Yeah, exactly. So this one here, you have from here, from this step up here, we conclude that x times x plus 3 must be equal to -2. Then now you have to solve this by distributing. You follow that? Okay, so you get 3x plus, well, actually, x squared plus 3x must be equal to -2. So do you follow how we get x squared plus 3? Said yes. Okay, good. And just solve for them. The rest you're okay, right? Okay, who else didn't follow this? So are you okay with this now? Okay, looks like we're really okay. So let's move on to the next example then, the one I asked you to do it on your own. Okay, who wants to go over this with me? Looks like a lot of you already done this. I have a check mark under my name. And I'm gonna. Who wants to grab a mic? Okay, let me put a clear check mark. Anybody who has a good mic and know how to do this wants to go over this thing to the check mark. Margarita, you want to tell me? Go ahead. What would be your first step? So I have to
get the base to be the same.
Okay. How do you do that?
I think it was 3 to the power of 4 is the same as 81.
Very good. So you're going to make it 3. And then what? How do you move that off now?
You make it 3 to the negative 4.
Very good. Okay, on the other side here, now I have the base the same, so the exponents must be the same. So what would be my next step?
You combine, I mean not combine, you multiply 3x x minus 5.
So you're saying that this base must equal to this. So now you distribute.
Yes.
So you get 16x equal to, right? So you add negative 4, positive 4 to both sides of the equation.
You add 4 on both sides.
Okay, so what do you get?
So you get 3x squared minus 15x plus 4.
Okay, so Jim, how do you factor this?
What was it? 3x? Is it 3x?
Yeah, put 3x and x, okay? So what are you going to put?
Now
4.
I'm stuck. Now I'm not sure.
Possibilities for 4 would be 1 and 4, 2 and 2.
2 and 2.
So anybody have a suggestion? You can type your answers since we have a mic. Jim has a microphone now. So what are you suggesting anyone to factor this? Will you use 1 and 4 or 2 or 2 or 2? Okay, we're missing an x here somewhere, right? Is that what you're saying?
I got it. For some reason, I wrote down that I got different answers or different ways. I'm not sure. I'm not sure what happened. I guess I did it wrong or something.
Actually, no. What's going on here is there's extra 3 here that just detected. I see that. See, the problem with this program, for some reason, it just delete the question. Okay, so let's correct this right now. So this one is the original problem. The exponents is x times x minus 5, and now this becomes 3. This is supposed to be x.
Oh,
so now we can. Okay. Yeah. Somehow this 3 jumped up there. Yeah. Okay. So we have to be careful with what I write here. All right, now it makes more sense. There's no 3 here.
Okay.
Okay. All right, so now it makes sense. There's no 3 here, basically, right?
Yeah.
So let's clear this up.
There we go. Okay, that looks like mine.
I think that looks better now, right? So that would
It'll
be
be
x
squared
squared. Now,
minus
by the way, if
5x
this were factorable, yeah, if this were factorable, you could
Yeah.
always use the quadratic formula for that, you know. That's no problem. But now you see
Yeah.
the problem here. Now
So
that's how
when
you.
I factor it,
Now,
it's
now,
going to be
now it looks better.
yeah.
Now just
Now
double
the
check
factor is going to be
everything
x
is
minus 4 and x minus 1.
What 1 and 4 is that what you want to put? Yeah. So both has to be a minus. Yeah, now that looks a lot better.
Yeah.
So x is equal
It's going to be
to
x equals 4 or
1, 4. And by the way, like I said, if this weren't factorable, you can always use quadratic formula. As I showed you last time. But yeah, that was just a simple error up there that somehow we jumped up there. Okay, thank you for detecting that. So that did detect that. All right, so then you can check the answer, of course, by going back and placing those in the right place. So this would be another example here. Solve the equation for x. Now, when the variable happen to be the exponents, like in this case, what you can do is you can take a log of both sides. So you can move this x to the other side. Remember this property we learned? If I have log of x to the power of n is equal to n log of x. So if you're solving for this n, I can move this n right front of this. So this you're solving for x. If I take a log of both sides here, if I take a log of both sides, this x here can go right front of log, so I can solve for them. That's basically what they're doing here. See that? So by doing that, then you can divide both sides by log of 4. So x would be equal to log of 25 over log of 4. So the solution would be log of 25 over log of 4. Or you could actually take a natural log of both sides to get the same result. Then you can use your calculator here for completing that. So let's take a look at this example here. Okay, this we don't have to pause the session because it was pretty simple. Can somebody who just saw what I just did go over this, tell me what would be the first step? You get the exponent, the variable that you're solving for happen to be the exponents. You cannot make the base the same here. When you cannot make the base the same, then what do we do?
Would it just be log of x equals log of 32?
You take a log of both sides, that's what you do. Okay, and then what do you do next?
And then you move the x over in front of the log.
Right, you move the x right in front of that. And then how do you solve for x?
And then you divide log of 5 on both sides. And then you would get log 32 over log of 5.
Yes, this is 5. Okay, so yeah. So then use your calculator to solve for this.
Okay.
Okay. Good. So solving exponential equations, there are some steps here that you can follow. Step number 1 is to isolate one of the exponential expression in the equation. Step number 2 to take a logarithm on both sides of the equation or the natural log. We have to use a calculator, of course, and use the power property of logarithm to move the exponents p right front of that, right there, and then you solve for it. So this would be another example here. So this is where we have e to the power of minus 3.6x minus 2 is equal to 7.74. So what we do is we add 2 to both sides of the equation, and then now we take a natural log of both sides because it's e. Remember, to have natural log of e to the power of x is equal to x, or e to the power of natural log of x okay, this was very similar to this property we learned. Remember, we said we have log of, this is the same kind of variable here. We have log of e to the power of x if the base is the same, this whole thing is equal to x, or if I have b to the power of log of b to the power of x. So these two properties are very similar. So if because the base here is e already. If the base of the exponents and base of this natural log are the same, the whole thing is equal to this number or term here, basically. That's exactly what it is. So I take a natural log of both sides because the base here is e automatically. So this whole thing is equal to, you can move this right here, move all this stuff here, right front of that's exponent, and then this will be just 1, and then x would be equal to natural log of this number over minus 3.6. Then you have to use a calculator to evaluate this. Okay. In all these problems also, if you go back to your ebook, you would see these kind of examples with the embedded lectures next to it. Those would be a good one to review as well. This would be another example to solve. Okay, here again, we cannot make the base the same like we could on the other problems. So you take a natural log of both sides this time. Alright. So if I take a natural log of both sides, I can move this x plus 3 right front here. And then to distribute this, this would be x log of 2, 3 log of 2. And then since we're solving for x, we're going to move all the terms that contains x to one side of the equation. And this is just a constant, goes to the other side. And remember the property that we have here. In this case, we can factor the x out now, because that's what we have in common. So therefore x would be equal to minus 3 natural log of 2 over natural log of 2 minus natural log of 7. And then you just have to use a calculator to get the solution set here. Okay, any questions so far? So let's kind of review all the property one more time of the logarithm. Make sure you have all these in one place. Okay, so I'm just gonna use this okay, so forget about all this for now. what we're going to do is we're going to review all the properties that we got for logarithm. Just do the blank page to find one. All right, there it is. So if I have the first one, if I have log of x is equal to y is equal to log of x to the base b. Then you can write this as b to the power of y is equal to the argument x. That's the first thing you have to remember. Okay, the next one is if I have log of x plus log of y, you can write it as log of x times y. Remember the base has to be the same. I have log of x minus log of y. So the same as log of x over y. If I have log of x to the power of n, I have to move the n right in front of that. The base has to be the same. And then these three also works for the ln. ln of x y is equal to ln of x plus ln of y. Same. ln of x over y is also equal to ln of x natural log of x minus natural log of y. And if I have natural log of x to the power of n, it will be n times natural log of x. So these are the properties that you need to know to simplify all those problems for the logarithm. Okay. Any questions so far? So what you need to do at this point is to go over all the problems for these two chapters that we covered last Monday and today. Best place would be to review this would be your ebook, and then maybe play some of those embedded lectures, and then right away you should start working on your take-home test. Some of you probably already working on the take-home test, which is great. If you haven't, make sure to print it and start working on the take-home test and take a look at the solution to each problem. You should have a solution for each problem embedded in next to the take-home test. The one version is posted already, which you can see the every single solutions directly to the YouTube channel. Or look at the complete solution. If you look at the complete solution, you can print the whole solution for yourself. And then bring your take-home test number 4 on Friday. We're going to review that before the next exam. The last chapter is going to be included in the final exam, chapter 9, which we're going to review at next Monday. And the next Wednesday we're going to review for final exam. Next week would be a good time to gather all your old exams and start make a list of the questions. And then I'll go over all those problems that you missed on the previous exam so you don't make the same mistake on the final. Let's do all that. So I'm going to stop recording at this time and then give you a few more minutes. If you have any questions, comments, you can fill it up. And then if not, we'll let you work on this problem. Don't forget that you need to work on these problems under the pie. Those are the problems that help you to practice and really understand the topics. You need to really complete them. So that's part of your grade as you know. Alright, so I'm going to stop recording at this time. If you have any questions, I'll be up here for next few minutes to cover them.